Hi guys, so this is your tutorial 7 for the psychrometric chart. This is still your topic 3 for your heat and thermal insulation in building, but it's the final part of the topic lah. So there's 3 questions. The first question here is very similar to the example you encountered in your lecture slides. So you are given 2 streams of air. You have to find out what's the mixed air dry bulb temperature and wet bulb temperature, and also the relative humidity. So here you have a fresh air which is 100 meter cube with 32 degrees Celsius dry bulb and 25 degrees Celsius wet bulb, and you are given also a recirculated air which is 150 meter cube or 20 degrees Celsius dry bulb and 18 degrees Celsius of wet bulb. So it's a mixture of these two together. You have a mixture of 250 meter cube of mixed air. So with that information, you'll be able to mark out your point in your psychrometric chart. So for the first point, which is for your recirculated air, you got a 20 degrees Celsius dry bulb. So dry bulb, you can refer to here down there the scale at 20 degrees. So you draw a line up, and then the next is you have a 18 degree wet bulb. So your wet bulb scale is here on this line. So 15, 16, 17, 18. So 20 and 18, this is your point 8 for your recirculated air. For your fresh air, it will be here. So fresh air is 32 degrees for your dry bulb. You draw a line up, and then it's 25 degree for your wet bulb. So you draw a line in between these two, and then you give a ratio of 1 to 1.5. Then you'll be able to get the point for your mixed air. So with that, you'll be able to find out that the mixed air have a RH, the relative humidity of close to 72 degrees. So it's just slightly above the 70% of the RH. And then you have close to 21 degrees Celsius of the wet bulb. And if you were to draw a line down, you have close to 25 degrees Celsius of your dry bulb. So a wet bulb is over here, the scale, and your dry bulb scale is over down here. So you will get something like this. Your dry bulb is 24.8 degrees Celsius, and wet bulb 21 degrees Celsius, and your RH, relative humidity, 72%. Okay, so for your question 2, you're given an external air at 4 degrees Celsius. This is your dry bulb, and 80% RH, relative humidity. So this is, and then you're heating up this air to 20 degrees. So you have to find what is the RH of the heated air. So for that, the first one is pretty simple, straightforward. So your dry bulb, is at 4 degrees, which is here. You draw a line up, and you're given a RH of 80%. So you follow this line down. So this is your first point. And then you draw a line all the way towards here. And then you are heating this same particular air to 20 degrees. So when you heat this air to 20 degrees, the relative humidity changes. So now you have to find what is the relative humidity of the heated air. So with this point A and point B, you'll find out that your RH, by referring to this line, 25%, is just above and in between the 25% and 30%. So it's about 27% relative humidity lah. Okay, so for B, what if the heated air is added with 0.006 kg of moisture? So when you add 0.006, you have to refer to here. So from 4, by adding 6, this will be your new point for your air. So it's asking you what is the RH when you add it add in the additional moisture. So when you add in the additional moisture, when the mark is here, referring to your RH, you have close to 70%. You have a 68% of your RH, so it's close to 70%. And finally, C, what is the increase in vapor pressure between the two states? So it's still these two. So when it's asking about the vapor pressure, you have to refer to this scale. So previously B, you refer to this scale. This is a humidity ratio, and then for C, you have to refer to this scale. So you draw a line here to here. This is the added moisture content, and then this is the original. So you just get 12 minus with about 4.8, and this is your new increased pressure, which is 7.2. So this is how you answer for question number 2 lah. And for question number 3, you're given the surface of a wall with a temperature of 11 degrees. And your air is 14 degrees. And it further explains that the air starts to condense on the wall surface. So this 11 degrees on the wall is actually your dew point or dew temperature. So you have to find what is the RH of the air, and also what is the reduction in moisture content necessary to lower the relative humidity of the air to 50%. So with this dew point, 11 degrees Celsius and 14 degrees Celsius of the dry bulb temperature, you'll be able to find what is the RH of the air. So you know that from the scale, 14 degrees Celsius, from here the dry bulb, you will just draw a line up. Okay, but for your dew point, you know that your dew point is 11 degrees. So you have to draw a line straight horizontal this way. So with the 14 degrees Celsius of the dry bulb intersect with this 11 degrees Celsius of the wet bulb. So for wet bulb, you have to draw a line. So you don't refer to this slanted line anymore. So you draw a line, you'll get this is a point for your air. So it's asking you to find the RH of the air. So by finding out your first point here, you'll find that your RH for this air is 80% relative humidity. Okay, so 80%, to reduce it from 80% RH to 50% RH. So with still the same temperature, within the same temperature, from 80% to 50%. So you can just draw within the same line. This is your point B lor. So from point A, with this information, and from point B still on the same line, but with the 50%, you have to draw a horizontal line towards. So you get to reduce the humidity, to find out what is the reduction in moisture content necessary to lower the RH of the air to 50%, you have to refer to this scale, the humidity ratio. So the first original one is at about close to 7.2, 5, 6, 7, 8, 8.2, and this is close to about 5. So you minus them together, you get a reduction about close to 0.003, as you can see here. So you need a reduction of 0.003 of the moisture content, and you'll be able to reduce the moisture relative humidity from 80% to 50%. Okay, so this is how you do for your tutorial question. So if you have any question, please feel free to ask. And thank you for your time and for listening.